Okay, let's wait like just a minute and start. Maybe Daniel, so we know each other. Can you do some intro?
Yeah, sure. And apologies, I look a bit flustered because I had been cycling this morning with my wife, and there was a big traffic jam, so I hadn't had the time to properly kind of wash up. So at least my apologies for looking a bit like this. But happy to join. I'm Daniel. I live in the Netherlands. I have a background in physics, and I've been working in the data science area for over 20 years now. On the one hand, I'm a freelance consultant working a lot with healthcare and public organizations in the Netherlands. And on the other hand, I have a part-time appointment at Eindhoven Technical University, where I teach postgraduate and also support PhDs in applying machine learning in their work, in their area of research. And the reason why I reached out to you is that I'm involved with Farm Access, and I've actually been involved in a lot of healthcare-related data sharing projects, where semantic standardization is really one of the key challenges. So within that context, I'm quite active in the Dutch area. And I'm also a representative of my university in a couple of the national working groups to come to better data sharing in the Netherlands. So that's kind of the background that I have.
Thank you and welcome.
Thanks.
Okay, so let's start. Let me share the agenda. Come on. Sorry, 1 second. Okay, so today I prepared the demo for Spark Postgres and a little bit more, and then we will listen Daniel about analytics for MomCare, and then start some discussions. Anything else, guys?
I think it would be good if Dan, when he joins, he also presents some of the use cases. Because he's been talking about a few and he has some ideas in his back of his head as he does so, but it'd be good to have a context shared. And thinking about it now, Evan, if you two could also lay out the use cases that you work with day in and out, that'll be very helpful to set the context.
Yeah, absolutely. We can talk about a few of them.
Okay, so cool. So I will try to be quick. So what I did, I did an experiment. So I'm quite experienced with Postgres. I didn't work a lot with the Spark and other columnar stuff. So I decided to familiarize myself, because we still have this dualism between the columnar and JSON native stuff. So I started from Cynthia files, then applied some simple transformations to these files. Then I used Spark to deduce a schema and convert it to the Parquet. And then looks like Parquet is a very nice format, because I was able to load from Parquet to ClickHouse native representation and DuckDB native representation, and eventually I will probably be able to do the same stuff with the BigQuery and Redshift. So here is a samples of transformations I applied. So they are under discussion. So, but I just will show to understand. So, for example, you see the category, which is yeah, it's better to see it like this. You see the category, and it's hard to search through this stuff. So here is a self category codes generated, which is a array of system pipe code. This will allow us to search by inclusion into array, like array contains some code. The IDs in references are parsed. And here is the experimental stuff that I indexed this component of observation by code. This is strange stuff, but it's just as experiment. And for the
quick question on the last example before we move on.
Yeah.
The transformations you're applying here, do they also, are they expected to retain the original data? Like when I look at components, I don't see the normal component array. I only see
it was retained. Yes, I just removed because too huge.
Okay, you just cut it down to show on the screen. Cool.
Yeah.
Thank you.
So it's preserved, yeah. So, and most of transformation are lossless, yeah. So then for the patient, something interesting, it's about extensions. So the very simple algorithm applied, like taking the last part of the URL, making it wallet identifier, like replacing dashes with underscore, as well still preserving URL. And the nested extensions are done in the same way. And all the extensions are arrays. So here should be array. So it's just formatting stuff. So then, then I tested again all the stuff like pass joins, working with codes, working with extensions. So here's a quick summary. I was able to run the queries on all these databases. The difference is how we access an element of nested data structure. Like in Postgres, maybe you know it's done like this, and array contains operator written like this. In Spark, you can do like using dot, and index starts from 0, or using square brackets to accessing nested elements. In DuckDB, we have the same, but the indexing starts from 1. So, and we in Spark and in DuckDB, we have array contains. In ClickHouse, it's not so nice. So when you can access first level and first index, which starts from 1 by square brackets, but the next elements should be accessed if they are quoted by string notation, but it still works. For the strange names, instead of using square operator to access nested fields, you can use a function tuple elements. And for array contains, it has a function has an array. Okay, and in that data fusion is, I think, less powerful, but it still allows us to access the elements. Nested elements, it doesn't have the operation for containing element in array, but guys are quite quick, so probably it will appear. Okay, so then I can show you some queries, yes? So for example, this is a query, this is for the Spark SQL. And we're using dot notation, and this is it's not a lot of interesting stuff, but it just for the grouping, yes. But here is more interesting. So for example, that's how you can use array contains to filter some coded elements through this transformations of codes. And as well, I can show you quick demo. I will create a stand and share this code. So for example, so we can run this one. Now this is run on Spark. So, and here example of the join through sof ID. So it works quite nice. So here's an example of working with extensions, like sof extension.use arrays, blah, blah, blah. And because it is array, so we're accessing it through the square brackets.
Nikolai, can I ask a question about, I think the maybe the simplest query example you have for grouping observations by code?
Yeah.
Yes. When you group here by an array valued field like SOF codes, will that only match observations that have the same entire list of codings in them? Like if there were 2 blood pressure observations and one had an extra SNOMED code?
Yeah, I agree. So here, this is not completely kind of void stuff. So
no, that's fine. I just wanted to make sure I understood what it was doing.
So I think so Spark group it by just by value, like, and it's not sorted. So if different things will have different codes and in different order, that may be the problem. Yeah.
Yep.
So
okay, that's fine.
It's not ideal, but this is a good
starting point. And with Cynthia data, it all looks the same because there's probably only one. Yeah.
Another approach could be indexed by system. So then something more interesting may happen. Yes, but it's still just demonstrations. Yeah. So here we have a join. Join works for everything. Here we have accessing the extensions. So here, for example, when the component is indexed by code, which is as well not the strict algorithm. Yes, because there is an array of codings, and initial algorithm just taking the first code and index by it.
Yes, and you also don't include the system here.
Yeah. The system is nested inside, so potentially you can recheck this condition. Yeah. But still, if the component is coded with a multiple concepts, so there will be some ambiguity here. So we should use all codes, yes, and like duplicate this stuff. But it will provide for us something that you can, kind of see that it works somehow. And here is example how we can search by directly, but again, this is not very strict. Yeah, so this is just the beginning. So my intention was just to start this kind of experiment. It looks very promising. So I really like DuckDB, to be honest. I can show you the real queries just to quickly demonstrate. So for example, so this is a ClickHouse, and we can run some simple queries, something interesting like this. Yeah, in ClickHouse. So this is DuckDB. Oops. Yeah, with the join stuff. And here's the data fusion, which work as well. And looks like, so let's get back to the conclusion that looks like that JSON through the Parquet may be very interesting way to thinking about SQL on FHIR. The support of most of these technologies for accessing elements, some date functions, datetime functions, open the possibility potentially to use this format in all of these technologies. There's still a lot of questions what transformation should be applied. Maybe there's still some corner cases. And potentially what I think that we can invent some macro style SQL, which will be expanded. Like, let's say this is JSON pass expression. If it starts with a dot, so this is without table alias prefix. If it starts with a, let's say, observation, something like this. So, and this macro could be quite easily implemented. So I will try to create some demo and translate such request into, depending on technology, to specific path expression. So I think that's all I want to report. So I'm planning next week, I'm planning to create some interactive demo online, so people will be able to try all of this stuff and maybe make POC for these portable queries. And probably add the BigQuery and Redshift. Maybe you can suggest some other databases I should try. Okay, and so that's everything from my side. Any questions, comments?
Just a quick comment for me. This is extremely helpful and makes concrete both the things that work out of the box and what some of the syntactic differences are. So thank you for putting this together. Mm-hmm. And one question about especially some of the more experimental kind of transformations you're using here. Do you have a sense of how much they help in terms of the ergonomics of your query? Like, what do you have a sense of what the query would look like without indexing components by link code, for instance?
So potentially unnesting can be used. So this is so most of these databases support unnest operation, maybe with a slightly different syntax. So, but it's usually what I've seen from experience. It will kind of double the code you should write. So for components, it's very experimental. I understand. Yeah.
Yeah. No, I'm just thinking that with the introduction of something like macros, you already have the option of pushing some of the smarts into the macros, and so maybe you could get by with less special transformations. Like there's some semantics you could put in the macro, or some semantics you could put in the transformations, and I'm just thinking
I
less.
agree. Yeah.
But
that should be the subject of experiments. Yes. So because at least what I've seen, for example, for working with extensions without, for example, indexing extensions, especially for the nested, it sometimes getting kind of very strange. And I'm not sure that macros could be so sophisticated so it will be able to expand this stuff. So, but
makes sense.
So I think there's some working demo where people will be able to play. So at the first step, I can publish the Parquet files and ND.json files, so people can play by themselves. And eventually, next week I will prepare the interactive demo. People will try it, and I hope this will start the discussion of specific transformations, which we gonna do, and probably open discussion for the macro system, which we may work on, or maybe we will decide not to do this.
Yeah, the challenge you're going to run into with macros is, of course, you have to complete every possible variation that every database would have and weave that into your macro syntax. That's a tall order. If you miss even one edge case, then the SQL macros can't be translated into your target DB, and then you're in trouble. That's hard to do.
Yeah. The general idea was to keep these macros very minimalistic, like introduce very, very small number of function, like in this array contains, let's say, and age in years, or just age function, which may be expressed, I tested in most of these databases, and keep it very small and very straightforward. Yeah. So, and provide some reference implementation. So, and looks like if this macro is not going to expand into something like a nesting, so then it's for my opinion, it could be very simple. So an implementation in any language could be quite easily done. And other stuff that we can support this macro in reference implementation for most of popular databases. This may help people to kind of escape the complexity of the macro system.
Hey, Nikolai, do you know of any like ORMs or, something that could abstract some of this away? So you'd maybe write something in Java, right? And then it could produce all the different queries for the respective DBs.
So from my opinion, even if you will be able to find such type of ORM, so it will be just AST for this query, yes. So, I mean abstract syntax tree, yes. So you will essentially build this query. So we can try to do this, but I don't think it will save us, because so implement macro in different languages, in different runtimes for this string is quite easy. But implementing the same ORM for different technologies would be much, much harder. Because from my opinion, this macro system could be implemented like in a couple of pages of code in any language. We can do reference implementation in dynamic language and one reference implementation in, let's say, Java or something like this, or Go lang. So people can take a look and understand how to implement by themselves. So it's still just very primitive templating like Mustache or Ginger, even simpler, without ifs and other stuff. So just a few functions. But at least it's initial, my vision for this macro, to keep it very narrow and very simple, and just only put something which we really need. Okay, guys, any other questions, comments?
No, I just want to add, I think I'm the new kid on the block when it comes to really using FHIR in production systems. I've played around with it a bit, but I have used Parquet extensively, and it's actually my common practice. You know, any ragged JSON, I convert to Parquet first, and that so I can,
that looks very interesting because Parquet could be kind of the interoperability format for us.
Yeah.
Because if you have a Parquet, you probably will be able to load it in most of columnar databases.
Exactly.
So
and down the line, you can because it ties into Arrow, then you can do a quick in-memory swapping, which is the whole promise of the Apache Arrow project.
There's still question about the strict schema. As I understand, we don't have guys from Bunsen project now, so they try to generate schema ahead. So I just used Spark deduced schema.
Yeah.
So, but still, maybe for analytic, it's not so critical, like to generate the schema ahead. And this idea that we can use Spark to deduce the schema and provide the Parquet file, they maybe will be not very compatible between each others. Yes.
Yeah. So, there's this issue with dynamically deducing the schema. Well, so oftentimes the way that this is done is heuristic, right? They'll look at some of the first rows or the first n rows and try to find the shape of that data. And in FHIR, there's a few reasons why you can't just do this once ahead of time, right? You have these recursion points where things can be nested arbitrarily deep. Any real data set only goes to a certain level, but the schema itself is recursive. So I don't know whether it's important to be able to convert dataset A into Parquet and then convert dataset B into Parquet and then use them both. If we say that we do need that, we're really looking at JSON as the lingua franca, and then the Parquet schema is something that gets layered on after the fact.
Yeah. And I would suggest that we can have kind of two primary formats. It's a ND JSON and Parquet. So if our spec will provide this stuff and samples and a reference implementation for that, so probably the rest can be done. And eventually maybe we will kind of create somebody will create the framework to generate schema ahead from profiles and other. But for me, it looks very promising. So I was able during the day having Parquet around like 3 databases, and I'm pretty sure that BigQuery and Redshift will be really quickly because I found that it's quite easy to load data from Parquet to BigQuery and Redshift. So, and that's amazing progress in this area. Yeah, thanks to Parquet.
Yeah, both Google and Microsoft are using Parquet heavily in their FHIR analytics pipelines as well.
I would even suggest that like bulk export operation for FHIR should export in Parquet.
I mean, everybody is doing that eventually anyway, right?
Yeah.
They're all just taking JSON they get from APIs and turning them into something better anyway.
Yeah. and I did some basic performance tests, and I'm very impressed by DuckDB. So it's really even better than ClickHouse. So that's very interesting.
So Nikolai, you said you were going to upload some sample files.
Yeah, I can quickly share the Parquet files.
Yeah.
So I can just put in public bucket and put the link on the GitHub repository so everybody can play it.
Yeah.
So I would recommend just install DuckDB and start working with the Parquet files. So it's very easy. So you can use Parquet file as a table.
Mm-hmm.
So, and next week I'm planning to create some interactive demos so you can write the SQL on the web server and choose the database and run this query.
That would be very cool.
Macro. Okay, so let's move further. Daniel.
Yes, thanks. Yeah. Could you give me some guidance how much time I can use for this?
Like 5-10 minutes.
Okay, I'll do that. What I'll do is I'll give a very short introduction about what Farm Access is and what we're trying to do, and then cut the chase and really because I'm very keen also to get your input and experience on all of this because we're literally just trying to standardize the work that we've done. So the project is called Data Care. And our aim is that we want to enable data sharing as an enabler for improved healthcare in low and middle income countries. That's what that abbreviation means. And I'm here on behalf of Farm Access Group. You can Google them. They're a large NGO, and their history is, well, they've been operating in Africa for a long time. And just to give you an idea, the Farm Access Group has many different activities, including funding healthcare clinics so that we actually have healthcare facilities in Africa. We're particularly active in these 4 countries in Africa, Kenya, Tanzania, Ghana, and Nigeria. And in the history, the Farm Access Group was founded by Joep Lange, who was a big advocate of making HIV medication available to African people in the 1980s when Africa was severely hit by HIV. So that's a bit about our context. I can share some of these slides. There's more links in there. And then zooming in, I'll skip the video, but basically we're looking at MomCare. And MomCare is about providing care to pregnant mothers. And as it is today, maternal mortality and child mortality in Africa is still something like of a factor 30 higher than it should be. That's what we aim to reduce. It's one of the Sustainable Development Goals. So we're here to improve healthcare specifically for MomCare. And MomCare has been active for over 5 years now. So it's active in Kenya and Tanzania. And I joined Farm Access about half year ago with the assignment, how can we scale it up? Because we have this whole idea of how we can improve the healthcare system in low and middle income countries, specifically for maternal care. But how do we scale it up? Because it's currently very much tied to very specific custom-built solutions. For each country, there's a different technical solution. So it's my task to come up with an architecture which can be deployed widely and which can also be adopted in a kind of open source fashion rather than having closed source system, which is currently the case in most countries. I'll skip that. And to give you an idea about the data set, we're basically looking at value-based healthcare, but then in a low resource setting. So in the case of MomCare, we're looking at a patient journey of a pregnant mother where we collect these type of data. We have something like 4 antenatal care visits. We have the actual delivery, and we have typically 2 postnatal care visits and immunization. So it's a very clear-cut episode. That was one of the reasons that Farm Access chose maternal care as one of the pilot areas, because after 9 months or 10 months at most, then the episode can be closed. So it makes it a bit easier to experiment with digital health interventions. For example, if you take chronic care, then it's an ongoing process. So this has been in place for over 5 years, and the question is how can we scale it up? And the challenge is really that there's no clear-cut pathway to go from pilots to nationwide deployments in Africa because of resource constraints, lack of standards, competing interests, and basically it's a wicked problem. We are writing a paper on this to just lay out our thinking and our experience up until now. And our approach and I will share that paper once it's available, is that we really want to focus more on a paradigm shift rather than, think of a golden egg solution and then top-down push for wide adoption of that. We really want to push the boundaries of digital health in Africa, but we do not want to be bleeding edge. So we have had our fair share of being a bit too optimistic about new technologies. And we do want to focus on interoperability. So that's how Farm Access tries to approach this. And basically, the very simplistic view, this is a kind of a management overview of our project, is that assuming that we have an engagement layer, typically it's tablets, Android tablets used in very small and remote clinics in Africa. That's basically the source of system of record. That's where the data is actually entered. And we're looking to design and implement this, what I call operational layer. which really leverages the FHIR standard. And I was happy to find that the FHIR bulk API is now also readily available. And this is then this operational layer. That's what we want to demonstrate using open source technologies. So we're in fact taking the approach by integrating the most common implementations of the FHIR standard. And our intention is that we want to publish that that's integrated set of components as a kind of digital public good, so that it can be deployed across many African countries. But what are the challenges? Because it's so resource constrained, and there's a paper which is referenced here, which kind of reviews what you need to take into account. I won't go into all the technicalities, but particularly the bottom one is, for now, I think the one I want to focus on. We have very serious technical limitations. Internet is intermittent, so whatever we design, it needs to be resilient to internet outages. So we have this kind of synchronization mechanism in the way we work today. So that's kind of the setting. And where are we now? What I've done is, these are, again, a bit simplistic architecture views. COT is the actual app that we have running in Tanzania. We're actually piloting this in Tanzania. Currently, it's a custom-built data model, and we have demonstrated as a first step by transforming that data model into the bulk FHIR standard. So we've built two components. One is basically just a Python transformer, where we just natively write MySQL and output it into conformed, plain old vanilla FHIR resources. And that's our starting point. And we've actually done analysis on that. And it all looks good. It's lossless. There's no loss of information. So it all seems doable, which already was an important proof point for us, because quite a few colleagues in the countries are quite skeptic whether this is not too much of a good thing to invest so much time ahead in standardizing the data. And that's what we want to demonstrate. No, it is possible. And ultimately, what we want to, I will come to this, is the type of end product that we need are typically these type of dashboards, which are used in the operational, day-to-day operations of the clinic. Because the care models that we facilitate are very much still process-driven, because we don't have that many healthcare-related outcomes data yet. So basically, we incentivize the clinics and the mothers to follow up on the WHO standard of having 4 antenatal visits and 2 postnatal visits during a pregnancy. That's actually, putting it very black and white, the key thing that we want to stimulate. And then there's conditional cash funds based on that principle, and that's how we want to get this virtuous cycle of improving trust and improving healthcare utility in Africa. So you can imagine, if you have, we're currently generating these dashboards now in each country with tailor-made systems, and that's what we want to generalize. And to give you an idea, these are the resources that I used to map the existing Tanzania data into plain old FHIR. So we're looking at something like 10 FHIR resources. And on the data model level, there are no impediments. The lack of data or incomplete data is the biggest challenge as ever. And also, not all African countries have a unique identifier for a person, which is also something we're looking into. But ultimately, what we're aiming for then is, if we can define a standard SQL, and that's another important point, whatever we build, we want to make it accessible for African companies or entrepreneurs, or to foster local initiatives that they can actually start doing this themselves, rather than being solely dependent on typically Western or even Asian tech providers. We really want to enable self-reliance in that way. So during the past months, when we iterated on the data care project, I had discussions also with the people at farm access, what's feasible if we really want to make a paradigm shift and make this accessible also for local developers and local analysts. And currently our thinking is SQL is here to stay. SQL is going to be the lingua franca, which is also more readily accessible for African analysts or African developers in due course. And that's how I found out about SQL on a FHIR, and I thought, well, if this works, so the combination of the bulk FHIR API, which is now available, and SQL on FHIR, my thinking is very simple, namely, even without a full-blown FHIR services layer, you could just have a FHIR-conformed data lake using blob storage, which the idea is that we're going to deploy this per district, because also the way the governance works in these countries is usually per district. And in my thinking is that this is possible, with quite lean and mean technology. We're not looking at terabytes of data. I really think that with DuckDB and using plain old blob storage, we could cover a lot of the use cases on the district level. And then this network, literally these FHIR data stations, if you will, would be typically something like 20 districts in a country like Tanzania. And that's a very lean and mean architecture, which is also affordable, because affordability is also a big design criterion. So what I want to focus on, and I would love to get your feedback on in whichever shape or form, and I happily contribute as a use case, is this doable using SQL on FHIR, where my thinking is that if we could just take that step and standardize the queries, they're already interested. We have interest from analysts, policymakers at the district level. We have a couple of teaching hospitals in Tanzania, and enable these type of personas in analyzing the data using standardized queries, because that's what we're aiming for. So that's kind of what I wanted to do.
Mm-hmm. Thank you, Daniel. So you're doing the great work.
Well, thank you. It's very interesting anyway.
Yeah. And from my opinion, it should be possible, and it looks like very nice use case and probably even pilot for SQL on FHIR.
Mm-hmm.
So it would be nice if you get into details of the dashboard. So I think we can start from the small.
Yes.
And let's try to design the queries which can populate the dashboards.
Yes.
Well, through these queries, we can exercise our transformation we would like to apply.
Yes. Well, yeah. If that's something that we could help each other out, then that would be marvelous. That's what I had in mind, and also that's why I pinged on the GitHub that when I did my desk research, I came across DuckDB. I didn't know about DuckDB until 2 weeks ago, and I was also quite impressed the way it performs. It's native C, and I can exchange those files, as a file. So we're investigating whether just having a simple file system on any old blob storage together with DuckDB in a read-only mode, whether that opens up the route to have this, offline resilient dashboard. Mm-hmm. We're also investigating, I work in Python most of the time using visualization libraries like Altair or Streamlit. So we're also investigating, someone ported Streamlit to WebAssembly. Well, if that works, then my kind of, short-term solution, which would be really a nice demonstrator, a WebAssembly dashboard, which can be deployed on Android tablets in the clinics in Tanzania. Mm-hmm. It just push the data in very compact and efficient DuckDB format, and they would run it. It would populate the dashboard, and I think that would be a major step forward.
Yeah, everything sounds very real. Relative to what we're trying to achieve, and your use cases would be very nice to support. And so I think so to start, so it would be nice to have some anonymized or maybe synthetic set of realistic.
Yeah, I was thinking that because it's relevant to note that the equivalent of the GDPR, Europe, is actually being implemented in both Tanzania and Kenya, and people are quite strict about sharing. And literally one of the things I had in my mind, if we can come to some kind of collaborative working mode, then I'd happily spend the time to generate synthetic data. So we can actually develop the queries together as a specific use case.
Probably the Cynthia framework may be used for that. And so you can do the project and try to generate, for example, data which looks like you have on Africa side. So then we can apply our reference implementation to transformations and create these use cases like SQL queries, which will drive the dashboard.
Oh yeah, I hadn't thought of that. I'll have to look at Cynthia and see the resources which are on our list and just subset that from Cynthia, and if that has the same structure, then that's good enough. Yeah.
Yes. Cynthia has quite. I think it's written in GRuby, so and quite simple rules, so you can kind of craft your. It's already have different data set generations rules.
Okay.
You probably can plug your own.
Yeah.
And create this generator, for your district with some realistic distribution and data points.
Nice. Okay, yeah, that works.
Yeah. Then from our side, so we're gonna create kind of reference converter transformation library. Can be applied to I think to the NDJSON file. Yeah. So then you can get NDJSON in SQL on FHIR format as well. So it will depend on Spark, and but we will think so, and we'll be able to get a Parquet file probably from it. And
what I've done now, the NDJSON which comes after the conversion, so the FHIR NDJSON, I literally just try to ingest those with DuckDB. And I got an error because I think DuckDB indeed just looks at X rows at the top, and then somewhere down the line it goes wrong. If I just download the FHIR v4 NDJSON samples from the HL7 website, it runs without errors. But I presume because the resources are very small. So this issue about having or not having to define the schema ahead, I think, is one of the things that we need to tackle.
Yeah, but so I read about Spark transformation to Parquet and how they try to deduce a schema, and it looks like it's more stable than just trying few records.
Okay.
The top, so it's smart. It's really loads all the data, analyze them, and generates a schema. So
so it's not just sampling.
It's not sampling. So that's why that's my impression. So, and we can publish this. It's quite simple code. I can show it so you're loading NDJSON into that data frame and dump it as a Parquet. So
okay.
It's just a couple of lines of Spark code.
Okay.
But it will have dependency on Spark.
Yeah.
But it's still open source. Okay, so, and I think it would be nice if you can even maybe manually create some data points, data set, very small data set.
Yes, I will put that on my...
Yes, and then try to sketch the queries you want to run on top of it.
Yeah. That
will contribute a lot for us and help us to decide on transformation we should do or not do.
Yeah. Cool, thanks. Thanks for your time. And feel free to reach out. I'm on CQLab now, so any suggestions are...
Hey, Nikolai, what are some of your thoughts on what that transform layer looks like? Like, have you chosen a language, or are you going to do bulk updates, or will it have to kind of work with some FHIR servers? Will it have to do puts in, when you do a put, we'll have to transform from FHIR into the transform language and then back if you do a get. Have you thought about all that kind of stuff?
Yeah, I was thinking that so that as we discussed the principle, the transformation should be simple and straightforward. So in the spec, we can provide reference implementation of this transformation, like let's say in JavaScript or something like this. So which just demonstrated it's really straightforward. So the people can take a look at this transformation and write it in the language of the choice, like Python, Java, or something else. And so we can probably publish one open reference implementation, and then the rest, and describe the algorithm in details. That's what I've tried to do in an initial spec draft. So, but it should, and probably we should provide as well some test cases like, so this is a FHIR resource, it should be transformed this way. So the people, while writing their own transform implementation, they will be able to test it against the test cases. That was my plan. Maybe, yeah. I don't know.
That's definitely interesting. Like, because I kind of see if you're doing a get, like you're doing a query on this data, maybe you're populating a dashboard and all you want is one thing. But another time you might want to query the observation, right, as FHIR. So then you're going to need to transform it back. You're going to have to grab the whole table or whole row, whatever it is, and then transform it back. So you kind of have to be able to do all these different things depending on your use case. And obviously everyone has their own stack and language and everything. So
yeah, from this point of view, so we personally going to implement the commercial version of this as well. And it's going to be like two-way transformations. I don't think that we should be focused on a backward transformation from this representation back to the wallet FHIR, at least as a first phase. But we can try to keep the transformation like lossless, and still have the ability, or maybe even publish the algorithm how to convert back, like from this representation to the FHIR. But we're trying to focus on still mostly on like query side, on analytical part, to be on the first level, this transformation lossless, and keep the transformation straightforward and probably reversible. Or we can decide that it should be reversible. Okay, so that's good. Okay, guys, so we have like 4 minutes. Then Josh, what do you think?
I mean, overall, I think this is super promising. I think if we lay out a few of the use cases on the next call, that'll be a good help.
Okay. So Daniel, can we kind of try to work on use cases? Maybe let's take one very simple use case, like one piece of your dashboard, and try to work together on this. Or the most challenging, I don't know, something like this.
Yeah. I'm happy to. I'm just thinking, I don't know how much time I need to generate that synthetic data set, but we actually have the queries already, but then in some other data model, and I'll confer with the product owner from this dashboard to see what's the best way, which query is the best to start off with.
Yeah, maybe some basic initial queries can be done on Cynthia data. So if you take a look at Cynthia data and you see
perhaps that's the easy
similar. Yeah. So we can start on Cynthia data and now not focus on specific parts, but on some more
parts.
Queries and try to do this.
What we find is because we're constructing a journey with obviously the time axis, and you have different type of aggregations along the way. Getting that right is probably a nice use case to start off with, because this is for pregnancy journeys, but we have the same for chronic diseases. Construct queries that have to do to construct the journeys with different activities with different aggregation levels. But I will try to write down some kind of refinement. Is it best? I don't know how you worked to do that in the GitHub repo or
it's better to do it on GitHub repo on discussions. So we're gonna keep it for the history, like all these discussions. So bring some samples and ideas and start discussion there.
Yeah, then so I will investigate Cynthia, and I kind of do a refinement session with an issue on GitHub discussions, and we can take it from there, something like that.
And my intention to bring everybody to discuss the specific transformations, yes, but
yes, yeah,
I understand that when we will have the queries which we want to run, so we can discuss transformations.
Yeah,
how much we should transform. Even what about you? Can you bring some use cases?
Yeah. So what I'd like to be able to do is actually play with some of these files and get the data set that I can load into something like Postgres or something, and then I can write some queries and I can show you kind of where my brain is going as far as what I need out of this. essentially, what I'm thinking right now is this macro stuff's cool. We're going to need table valued functions probably. So that's going to have to be macroable. In these platform, the use case I care about will only work on platforms that allow you to define those and execute them. We may need aggregate functions as well, but I'm not 100% sure on that. That's a question mark, but I can propose how that might look. I'll use some really simple examples, but I want to actually be able to run actual SQL to see what the queries would look like, so I can then propose how the transformation might look and then see if this has legs, right? I can see if I can get that done for next week. I'll block some time on my calendar to play with this. So yeah, this is very cool. I like the macro idea. It'll make our lives easier, because for those of you who are new, I'm trying to convert CQL to SQL so I can do quality measurement using SQL instead of a domain-specific language, which would be nice, much faster. So I'm thinking about how I would translate my CQL into these queries. And with table valued functions, I can do it because I can polyfill anything that you can't do in SQL. So it's going to be a complex journey to fill in all those gaps, but it would open up hugely cool use cases. For example, if it's successful, it would obviate the need for CQL engines, because you could simply take a Parquet file for your JSON, load it into DuckDB, and then run the CQL to SQL conversion tool, and you don't need an engine anymore. You can just then execute the queries against DuckDB and you're done, right? That would be really cool. So I'm excited about this. It's cool stuff. I like it.
Okay, guys, thank you. So see you on GitHub and Zulip. So let's keep in touch. If any questions, contact me.